structure of striated muscle kaninang of striated or skeletal muscle that are attached to your skeletal system. How ka kaninang skeletal muscle in attach how ani skeletal muscle hi khoya nge I hmu kan ti chuan in limbs in ban te in ke te tiru chumi ba ka chuan in your inlay your tongue. Okay, chumi ba ka chuan pharynx ate esophagus ate in abdomen ate point muang. Okay, shem ru headline banvel chawami khan ni lo nia. Okay, chuan tendons mangin tough connective tissue called tendons in elastic fiber mangin muscle ani attach ani kanti kha in siatiru skeletal muscle hi uluk taka kan en chuan omzia chu enge headline hei in ban lo ni ta se headline muscle hi kan lak chua chuan muscle hi kan lak chua chuan enge siam tu kan ti kha muscle fiber in a siam ani hemi muscle fiber pakhat hi kan lak chua chuan hei hi kan en chuan uluk taka kan en chuan you will find something like this. Okay, something like this mo hetiang hin muang mo dayan at cha deu tep teping ka sia kang cha deu teping ka sia kang hetiang thil hi I muang masala chuan hetiang hian an lang do na ni mo ti hian an lang do na ni chuan ta hian a cha hin lenga a chan lenga a chan lenga chan lenga chan lenga jem ta hian a chan lenga chan lenga chuan a panan lenga jem chuan headline mi hi hei enge kan ti chuan this is what we call sarcolemma khani. Okay, muscle fiber tuam tu ko rakha a chung hi sarcoplasm kan ti chu nia muscle fiber hi uluk takai en chuan skeletal muscle chu striated muscle an ni kan ti kha. Okay, emwangin nge striated or striped muscle an ni kan ti chuan because there is alternate dark and light bands. Okay, ta hian alternate light and dark bands an umani muscle fibers a chuan. Okay, hitlai hi alternate light and dark bands umzia chu enge he lai a chau how na chin hi in hmu tiru hetlai chin hi we call it A band. Okay, A band. A for anisotropic. Okay, anisotropic kan ti chuan an thim nu tuka microscope nuai en bokhan light in a penetrate theilawa thim muk angin an langani. Okay, we call it A band or anisotropic band. Okay, also known as dark band. Okay, siang em chuan microscope nuai en chuan lighter region imuang. Okay, lighter region called I band. I for isotropic. Light can penetrate chuwang chuan microscope ai en khan an eng ani an lang eng kwar ani B kani hemi S compared to this. Okay. Chu tiang bokin helama hian I ben na uma. Okay. Chuan A ben na le a, I ben na le a. Okay, like that. Okay, he tiang bokin. Chuan I ben is also known as light ben. Okay, light ben kan ti buka. I ben, light ben kan ti hi alai taka hian sarcomere le sarcomere tantlang tu connective membrane na umani mo membrane na uma line angin na uma chumi chu we call it Z line kanti. Okay, we call it Z line. Okay, I ben lai taka tantlang tu hi we call it Z line. Okay, siang em chuan zia chu enge I ben hi en chuan enge siam tu hi heng hau hi pante te an ni. Okay, they are made up of thin filaments. I bens are made up of thin myofibrils or myofilaments. Okay, thin myofibrils kan ti chuan muscle cytoskeleton soinani mo cytoskeleton kan ti chuenge filaments myofilaments kan ti haute insiatiru. Okay, thin filaments hi asiam tu chu thin myofibrils called actin filament anni. Okay, actin filament ina siam anni a. Dark ben siam tu te hi an cha zo ka heng ho hi they are made up of thick myofibrils. Thick myofibrils called myosin filaments ani. Okay, myosin inan siam ania thick filaments hi thin filaments hi actin filament ina siam ani. Oh, you have thick thin thick filaments myosin ani hey actin filament. Okay, chuan A ben hi en chuan dark ben hi en chuan A ben a chuan myosin filament ba ka hian little bit of I ben thin filament mu te lang tiru zia chu enge A ben a chuan myosin filament le actin filament an ve ve ma se I ben a chuan you will find only thick filament thin filaments. Okay, actin filament chau muang I ben a chuan. Okay, light ben a khan chuan muscle contraction a khan I ben te hi an kara hian an run luta chu wang chuanin an run tom thin ani. Okay, thin filaments ho hi an run luta an run tom thin ani. Okay, chuan A ben hianin alai taka hianin center of A ben a hianin you will find what we call H zone. Okay, H zone a hianin enge kan ti chuan you will find only thick filaments. Okay, H zone a chuan myosin filaments ho chau na lai region hi H zone ani. H zone hi muscle contraction a chuan a ron zim don. Okay, muscle relaxation a chuan H zone hi azau se lang. Okay, H zone is also known as Hansen's line te pon ti chin ni. Oh, hei hi zaule zim na chance anei ti na ni chu. Okay, chuan I ben lai taka hianin membrane thin membrane I mua Z line I mua tiru khatiang chia khan A ben lai taka hian mo thick filaments how chau connect to membrane pan te a lai taka hian a umbe ni A ben lai taka hian we call this as M line. Okay, M line chu enge center of A ben ani chu. Okay, Z line chu enge center of I ben. H zone chu enge where you find only thick filaments. Okay, chiang em chuan I ben lai taka Z line hi mo hi myosin filaments anya actin filaments anya actin filaments anya tiru myosin anom lea actin anom lea myosin anom lea I successive I ben in chia tiru successive I ben zel in kara hian zia chuenge center of I ben chu Z line ani mo Z line of successive I ben hi a indota I ben zel in kar Z line le Z line in kar hi in hotiru this line and this line in kar hi. This is what we call sarcomere. Okay, sarcomere pakhat chu ni hei hi. Okay, inge chu sarcomere chu the structural and functional unit of myofibril. Okay, myofibril chu enge muscle fiber ani tiru muscle fiber pakhat muscle fiber structural and functional unit to sarcomere ani. That is the region between the region between Z lines of each successive I bends. Okay, chuan sarcomere hi muscle fiber a hian the length of sarcomere is around hemi le hemi inkara hi. Okay, this length is usually around 2.5 micrometer. Okay, lang between 2.5 micrometer ni. Micrometer kan ti chuan 10 to the power minus 6. Okay, zia chu sarcomere pakhat chu te takani mo ama ero chu muscle fiber hi chu elongated shape ania myofibril pakhat hi chu very elongated shape ania. Okay, hemi length hi the length of a myofibril. Okay, hilai myofibril pakhat hi a seizong hi it can be around 10 mm. Okay, 40 mm chu enge 4 cm vel dai ani theini mo muscle fiber pakhat seizong hi. Okay, average alakin 40 mm vel ania chuanin avanga hi. Okay, and diameter hi. Okay, this diameter can ranges between 10 to 100 micrometer. Okay, 10 to 100 micrometer velani and diameter hi. And length nen chuan a in thlau viau ani tiru and diameter chu very thin and elongated ani ti na ni chu narrow but elongated ani ti na ni chu. Oh, so this is the structure of skeletal muscle. Okay, insiat le tur chu electron microscope kan en khan thick film electron microscope kan en khan I ben siam tu te hi thin filaments ania A ben siam tu te hi thick filaments ani. Okay, ama ero chu thin filaments actin filaments hi achang chuan secondary filaments te pon ti thin. Okay, thick filaments ho hi primary filaments te po kan ti thin le khabu chen khata chuan primary filaments secondary filaments anti chuan buai chuan lo tur. Okay, buai chuan mi lo tur ni chumi ba ka chuan actin filament thin filament myosin filament thick filament ti kha an soi dan ani boka khatianga kan soi chuan buai chuan lo tur okay chuan ai be na thin filaments ho hi okay thin filaments ho hi enge an sei zong kan ti chuan the length of thin filaments could be around 2 micrometer okay 2 micrometer vel chawan ni thainia oh 2 micrometer chu toite ani okay chuanin actin filaments hi tu tenge asiam tu te kan ti a structure chu nakina kan da endon thawa okay tu tenge siam tu te kan ti actin chu protein ani okay protein ani a chuan protein actin protein in anin kha anin zom khoma sei takin anin zom khoma chu chuanin actin filament an ron siam ani actin protein molecule engza in nge filament ron siam kan ti chuan around 3000 actin molecules vel hian actin filament pakhat an siam okay 3000 molecules vel actin pakhat nei turin imamo tina ni chu okay chiangem chuanin myosin filament ve thung kha enge an length kan ti chuanin an seizong hi engchen vel nge kan ti chuanin they are only around 1.2 micrometer in length okay hey actin filament a hian an toi zo kani helai thick filaments ho hi oh chiangem an toi fe zo 0.8 lai velin anin thawani chu okay an length ta chuan an diameter kha enge niang kan ti chuanin actin filament myosin filaments ho kha an cha zo ka diameter of hemi diameter hi okay diameter of actin filament will be myosin filament will be around 100 angstrom okay angstrom in shatiru angstrom chuanin actin filament ho hi enge an diameter kan ti chuanin hemi chan ve vel chau okay only about 50 angstrom this is diameter okay hemi cha zong te hi only about 50 angstrom ti na ni chu okay 50 angstrom vel chau ani chuan actin filament chu around 3000 actin monomer actin molecule sinan siamani kan tia myosin filament hi myosin engza vel in nge myosin po chu enge protein thawani myosin engza vel in nge siamang kan ti chuan around 200 myosin molecules hian around 200 myosin molecules hian 1 myosin filament an siam okay chuan in shiat le tur chu myosin filament hian head an nei ni mo lu an nei thina nakina structure detailing ka shilang cheunga lu an nei thina chumi an lu awang chuan sometimes they form cross bridge okay this is what the hian anin connect thini oh sorry actin filaments tenen hian tian anin connect thini mo this is what we call cross bridges pakhat ay tamani chuan cross bridges okay hei hi enge cross bridges hi enge ron siam tu kan ti chuan myosin head of myosin hemi a hian head an nei ni mo chuan in shiat le tur chu thick filaments myosin filaments te hi they are free at both ends shiat tur mo an end len end hi a free ve ve ni mase engtinge together in an thei kan ti chuan m line in a connect kan ti kha sarcomere to sarcomere a connect kan ti khain shiat ru chuti rual chuan actin filaments ho hi chu sarcomere unit pakhata chuan 1N is attached to ZDs in siya tiru sarcomere helam hi sarcomere unit pakhatania N le lampang hi ZD sa anin connect zela the other N is free in siya tiru siya tiya mem chuan sarcomere unit pakhata hian myosin filaments hei hi neita actin filaments su abung ve in lelama ineita ni tiru an arrangement hi uluk taka kan en chuan an arrangement hi uluk taka kan en chuan ti hian hei hi thick filament lo ni ta se lai hian thin hei hi enge omzia kan ti chuan hemi hi a cross section zonga hi enin okay itan bunga apan zonga heti zonga hi en chuan alaya hian myosin filament na omanga okay thick filament ani hei hi okay myosin anianga or primary myosin or primary filament or thick filament khania chuan these are actin or secondary filaments ho khani anin arrange dan hi kan en chuan myosin pakhat hi actin filament paruk in an hual zelang okay omzia chu one myosin filament is surrounded by 6 actin filaments okay and therefore they form hei lai hian they form hexagon okay arrangement a hexagon an siamani chuti rual chuan tian lo ziak le taila khat ni thum li nga ruk parukin myosin an hual zelanga khat ni thum li nga ruk parukin myosin an hual zela in tiru hexagon an siama chuti rual chuan actin ve thung hi a position hi en chuan one actin molecule is surrounded by 3 myosin filaments in tiru one actin molecule is surrounded by 3 myosin molecules tiru one actin is surrounded by 1 2 3 myosin filaments myosin filaments that is why this arrangement is known as trigon okay shem trigon hexagon okay shetia mem kha an arrangement chung chang ani chiang em chu a chan chu hemi hi kan nei theina hemi arrangement hi kan nei na chan chu enge thick filaments te hi thin filaments te hi 1N na ZD san in attach lai hian lelama hian an free a ama ero chu i myosin head ho hian cross bridge an ron siam thinta okay cross bridge an ron siam thinta chu wang chuan microscope ai en pon thin filament hian thick filament an overlap ang kha na chang chuan a lang thinta ni helai cross bridge a hian in tiru chu wang chuan hemi arrangement hexagon when one myosin filament is surrounded by 6 actin filaments le trigon when 3 myosin filaments surrounds one actin molecules trigon arrangement kha inei ni masel omzia chu hei hi ti hian a phek do lawa amu mina om kha in sia tiru abial te in anom zel kha muscle kha hei hi muscle fiber myofibril pakhat chawani okay myofibril pakhata chuan myofibril pakhata chuan sarcomere unit tam takinei do na chan chu length of sarcomere is only 2.5 ani lain length of the myofibril is 40 mm ania mo 2.5 engzange nga yang unit engzange nga yang muscle fiber pakhat siam tu tam tak imamo don okay chiang em chuan ishiat le tur chu hei hi structure of skeletal muscle ani. Okay, structure of skeletal muscle ani heti ang arrangement of thick and thin hi heart muscle chuan a ve ma se heart muscle or cardiac muscle chuan a ve ama ero chu you will not find this type of arrangement in smooth muscle or visceral muscle or non-striated muscle. This is only the property of striated muscle. Okay, headline arrangement hi chu tlem te in lau nen khan cardiac muscle khan ron ang veang. Okay, smooth muscle heti ang hi mui tu mga ipmudon lo. Okay, chiang em le structure of thick and thin filaments kakan en lokang thick filaments kan en masaang myosin filaments, also known as secondary filaments or thick filaments. Kami ka a structure eng tinge kan en masaang myosin filament thick filament ka enge asiam tu kan ti chuanin polymers of myosin protein inan siamani myosin protein zahni vel in zom khom inan siam kan ti ni tiru myosin protein chu monomeric unit pakhat kan en chuan. Okay, single molecule of myosin protein kan en chuan monomeric unit zahni in myosin filament an siam kan ti khain sia tiru monomeric unit pakhat hi kan en chuan hemi monomeric unit pakhat hi this is known as meromyosin kan ti ni antini meromyosin nanti hemi monomeric unit pakhat hi a structure kan en chuan tian lo ziak ta ila. Okay, made up of sam takin tiang kan ziak mayang. Okay, hei hi enge kan ti chuan meromyosin pakhat ani myosin protein molecule pakhat. Okay, hemi hi a seizo nga hi a length hi engzange kan ti chuan this is about 1500 angstrom velani. Okay, 1500 angstrom velina siamania a diameter hi kan en chuan 20 to 40 angstrom velina siamani. Okay, chuan ama hi meromyosin pakhat hi myosin protein molecule pakhat hi 6 polypeptide chains sinan siam. Okay, 6 polypeptide chains anla in chen sang le ti na ni chu omzia chu myosin protein hauka anin zom khoma polypeptide chains an siama chumi polypeptide chains paruk ina siam chu ni mo paruk chuan meromyosin pakhat functional molecule pakhat an run siam te na ni chu. Okay, chuan a structure hi kan en chuan 6 polypeptide chain ina siamania chumi 6 polypeptide chain chu enge asiam 6 polypeptide chain te chu khoyange an kan ti chuan. Okay, hemi meromyosin molecule hi two parts ane ni. Okay, 2 parts or regions ane ya a globular region hi globular kan ti chuan a mum lam tiru globular region hi head kan tia chuan filamentous region hi a sei zonga hi we call it tail. Okay, head le tail anei ti na ni chu. Okay, chuan head hi arm toy te a in attach headlight te hi arm region chu ni chu. Okay, head is attached to the arm. Chuan head le arm hian they form cross link. Okay, cross link kan ti kha an siam ani. Okay, head le tail hian cross link an siama head region an okay, chuan head adang kha tail zia chuenge tail region is made up of 2 polypeptide chains. Okay, polypeptide chains pakhat pahnih in a spirally arranged manner. Okay, unintertwined ti na ni chu polypeptide chains pahnih te kha mo spiral angin aninrem ti na ni chu. Okay, polypeptide chain pakhat polypeptide chain pahnih ina siamani. Okay, this region is lighter as compared to this side. Okay, an molecular weight kan en chuan helampang region hi ta hian lo tan tai la buk tai la an zang zo ka chu wang chuan we call this region or tail region as light meromyosin kan ti. Light meromyosin short form chuan LMM. Okay, LMM region kan ti. Chiangem chuan a head region a hian globular head pahnih a oma tiru head pakhat pahnih oma. Each head is made up of 2 polypeptide chains. Mo polypeptide chain pahnih chiangem head pakhat khan polypeptide chain pahnih zel neya an pahnih chuan pali panga paruk zavain 6 polypeptide chains in asiam. Okay, hemi head region hi arm ne na cross link an siam hian hemi region hi molecular weight kan lak chuan arit fe zo ka chu wang chuan this region is referred to as heavy meromyosin. Short form chuan HMM. Okay, short form chuan HMM kan ti ni. Zia chu hemi meromyosin zatni vel hi anin zom khoma chumi chuan engen siam chu myosin filament of the skeletal muscle kha an siam ti na ni chu. Okay, myosin filament of skeletal muscle. Okay, chuan in sha tur poimo le chu myosin head hian meromyosin head hian mo a head hian active site anei ni. Okay, active sites pahnih ne yang. Okay, active site for this is active site for ATP binding. Okay, ATP binding site aneyang sites aneyang. Okay, chiangem ATP binding sites achan chu head a hian ATPase ATPase. Okay, zia chuenge enzyme an siam chuak ti na ni chu. Okay, myosin ATPase an siam chuaka chu wang chuan ATP an bind theya energy an siam chuak thei ti na ni chu. Chuan hemi arm le head hi cross link siam tu te hi actin site ne na cross bridge siam tu khani cross bridges kain na sha tiru tia chup chup kha khami siam tu te khan ni a engwangin nge cross bridge kha active actin filament nen khan engting nge an siam thei kan ti chuan a chan chu active site another active site for actin filament, or let's say actin binding sites an nei ani. Okay, active sites pa ni ti na ni chun lu a chuan okay actin binding sites and ATP binding sites hemi wang hian ATP actin binding sites an ni hetlai chia hian chuang lo nia just for example mo actin binding sites an nei awang hian cross bridge with actin filaments an siam thei pha ni hei hi. Okay, cross bridge with actin filaments an siam thei na chan kha ni. So this is all about the structure of myosin monomeric unit called meromyosin, made up of tail and head. Okay, head region is heavy meromycin, tail region is light meromycin. Okay, hei hi enge kan ti chuan myosin monomeric unit ani. Okay, functional unit ani chuan englo kan en le thungang actin. Okay, actin ve thung kha actin filament siam tu te ve thung kha actin filament kha actin protein sang thum ve lina siam mani kan ti kha in la sia tiru khami sang thum kha apakhat amal pakhat te in kan enang chuan in sia tur chu actin protein sau chu thin filaments kan ti zo kange. Okay, thin filaments or primary filament or actin filament siam tu kha engtinge kan ti chuan actin le tropomyosin le troponin hemi pathum zong hian thin filament an siam. Okay, thin filament or actin filament siam tu kha actin, tropomyosin and troponin an ni pathumin an siam. Okay, chuan actin chu enge ani kan ti chuan globular protein ania ero chu actin hi tiang kan sia kange mo. Actin can occur in two forms. Okay, form pahnia we call it G-actin and F-actin. Okay, G-actin kan ti chuan globular actin. G stands for globular. Okay, F stands for filamentous actin. Filament kan ti chuan say it. Okay, zia chu enge G-actin chu enge hei top hi ni mai G-actin globular protein ani G-actin chu mo mum top. Okay, this is G-actin. Amma ero chu in sia tur chu in the presence of magnesium ions. Okay, magnesium ions a chuan i muscle fiber a khan i muscle a khan magnesium ions a chuan atam chuan G-actin te hi anin zom khoma. Okay, anin zom khoma, they form a polymer. Okay, polymer ti hian an siam chini polymer kan ti chuan chains soina ni tiru thui takin ti hian anin siama polymer hi hemi polymer hi enge kha shui shualin chia tiru tia shuin shuala an intertwine chin ang khan okay chem heng ho hi lo ni ta se tia kal zok lo ni ta se mo tian local ta se adang zong hi pakhat line pakhat zok okay kazia khyam vak lawa shui shwal tia in shwal ang chia khan spirally in an intertwine na an intercoil da they form F18 okay hei hi enge G protein an in zom khoma F18 an siam filamentous actin okay G protein hawan in zom khoma magnesium omna hmuna chuan they form filamentous actin two forms in actin a thei tina ni chu a sei et le amalin okay globular topin an thei tina ni chu okay chuan ishiat tur chu hemi F18 hian active site anei ni okay active site chu tlai hian active site lo ta se tlai hian lo le ta se tlai hian lo le ta se okay hemi hi enge kan ti chuan active site for myosin binding okay myosin ne na cross bridge an siam theina hmun angkha tikhian active sites an nei thini mo myosin filaments ne na cross bridge an siam theina hetiang hi active site a hian hemi active site a hian they used to possess ADP okay ADP an nei tel thin engwangi nge myosin nen khan an in zom thei cross bridge an siam thei kan ti chu myosin het khan ATPase activity nei ta in shiatiru ATPase enzyme ne ya chuan hemi hian ADP alo nei boxia ADP molecules alo nei boxia chuan cross link an siama chuan ADP changkhan ATPase mangin ATP an siam chuakang cross bridges a line inche thiam tiru chu engti khuna muscle contraction a omin relaxation a chuan chu tiang chu thleng lawang okay so this is about actin G18 and F18 chumi ba ka chuanin tropomyosin kan ti ve thung hi nge kan ti chuan tropomyosin hi filamentous polypeptide thawani mo hetiang thau hian a sei in a oma made up of tropomyosin is made up of two polypeptide chains okay polypeptide chains in a siam ve thawani mo polypeptide chains khoyangen tropomyosin kan ti chuan F18 a hian hetia thil mum pahni khatia an intertwine kha chuan an inkara khan groove a don tiru a khuar ang kha dona khami khuar lai zela khan F18 te hi tian an lo in zep ve zelani mo an lo in zep ve ze ban tian an lo in zep zela a khuar lai a khan okay shem polypeptide chain pahni na siamani kan ti kha chu po chumi te po chu an intertwine thau polypeptide chain pahni kha shui shwa lang khan tian anin shwal ve thau ti na ni chu okay hei hi enge kan ti chuan tropomyosin okay tropomyosin ania actin groove a zel khanin an omang okay chuan F18 groove an zel awang khan spirally coil angin an omang shetia mem chuan ishiatur poimo chuenge tropomyosin hian tangkai na nei ni mo enge an tangkai na kan ti chuan muscle kha relax state a khanin muscle kha contract ring athiang lawa relax state a oma chuanin energy anei let le nga ya resting potential anei let le nga ni tiru na tho theile zel nang khan chu wang chuan resting stage a chia khan muscle contraction a lawa relaxation a khan resting stage a an lai khan tropomyosin hian hemitropomyosin hian they cover 7 active site of F18 okay hei F18 hian hetiang active site hi nei thin kan ti kha in sia tiru khami kha hei hian in resting stage a omin relaxed state a omin muscle relaxed state a omin 7 active site of F18 hi tropomyosin hian an mass ani an tuamani chumi chu a effect tur chu enge kan ti chuan binding formation of cross bridges between actin and myosin an prevent ang shetia mem actin le myosin khan cross bridge an siam lo chuan muscle contract don lo muscle relax ang okay aum zia chu they tropomyosin play an important role in muscle relaxation ti na ni chu okay muscle relaxation a na thok tu poimo ani ti na ni chu okay chuan headlight troponin ve thung hi okay troponin kan ti ve thung hi troponin kan ti ve thun hi chu filamentous tropomyosin anga filamentous ani ve lawa this is a trimeric oval shape protein ani ve thung okay khoyangen kan ti chuan 8 trimeric ka ti chuan made up of 3 subunits ti na ni chu okay ti hian subunit pathum te hi tian an nei don ti na ni chu okay pakhat pahnih pathum okay khoyangen kan ti chuanin regular interval sa ti hian anom thin mo I filamentous actin hian regular interval sa ti te hian anom thin king hau hinge troponin an ni okay troponin is made up of 3 subunits kati kha mo subunits pathum ina asiamania troponin te chu subunits pathum te chuanin complex an siamani mo chuan chumi trimeric protein pathum troponin ina anei te chu okay they are known as troponin I, troponin T and troponin C kantini mo troponin I, troponin T and troponin C kanti chiangem ITC mo short form in TPI TPC okay chuan hei hi troponin I lo ni ta se hei T lo ni ta se hei C ni don ti na ni chu complex of protein trimeric protein ani troponin chu regular intervals an umang okay chuan hemi subunit te hian role chi sang an nei ni function independent takin function an nei theu enge an function chu kan ti chuan troponin I hian ahminga po I ani hi okay gm enge engna nge tho kan ti chuan it inhibits formation of actin myosin or it inhibits actin myosin interaction kan ti nge okay ana tho chu enge actin filament le myosin filament in cross bridge an siam tur kha aphal lawang a inhibit ang a prevent ang okay engting nge prevent theyang by masking active site okay active site hi tian an lo hlia don ni hemi hi troponin I ta hian a umang shetia mem during muscle relaxation a okay active site for F18 active site for myosin kha alo hlia dai chuan myosin in a ron bind thei lawanga troponin in lo bind dai chuan cross bridge formation between actin filament and myosin filament atheng lawang shetia mem thil omzia chu ni oh chuan troponin ti ve thung hian eng hna nge atho kan ti chuan F actina tropomyosin run ve a khain sia tiru khami kha a bainang this will bind with tropomyosin ahminga po ti kan ti hi sia tiru it will bind with tropomyosin sia chu F actin le tropomyosin le troponin te kha an pathumin in zom khom vek don ti na ni chu o hemi filamentous chain a hian chiangem chuan troponin C ve thung hian binding site for enge ane for it possess binding site for calcium okay ahminga po C ni hi calcium lo bind tu ni chanchu muscle contraction and relaxation a khan calcium khan role ane ni tiru chu wang chuan nakina detailin mechanism kan enanga calcium lo bind tu poimo takani troponin C hi okay C is for calcium binding, T is for tropomyosin, I is for inhibition of formation of actin myosin cross bridge. Okay, so this is all about the structure of thin filament khani. Okay, chuan heti ang lir hi za thum velan in zom khom sang thum velan in zom khom chuan engen siam chu they form thin filament of the skeletal muscle or secondary filament of the skeletal muscle. Okay, lahian primary kalau tile man chong swal hi kachinga mo secondary filament or thin filament or actin filament. Okay, chiangem sliding filament theory kan enang inge sliding filament theory hi kan ti chuan this is a theory about muscle contraction theory chu chi hrang hrang a oma amai ro chu most accepted model is proposed by two independent groups of scientists known as Andrew Huxley le Ralph Niedergerg tian trang du na Hugh Huxley le John Hansen tian trang dun boka chuan chumi te chuan 1954 a khan sliding filament theory an propose ani chang chuan Huxley and Huxley model sliding filament model te pon ti chi na in sia tiru hemi hi heile he hin thok du na heile hen hin thok du na chuan sliding filament theory hi 1954 a run chuak ta a okay hemi hi sliding filament theory is based on changes in bending pattern. Okay, bending pattern hey hi a in nga na berani mo changes in bending pattern kan ti chu enge myofibrils a bend I bend te khai in sia tiru striated muscle a chau okay smooth muscle a te ani don naunia cardiac muscle a te ni don naunia this is only for skeletal or striated muscle. Okay, bending pattern da na zir khan kami bending pattern in thak le thak lo da na zir khan in hemi theory hi an propose ani mo sliding filament theory hi an propose ta chuan bending pattern chu engtin nge kan ti chuan muscle contraction a omin okay length of a band remains unchanged. Okay, a band hi engtik lai ma in a in thak dang lam lawang ti hin soi okay chuan adot le an soi chu enge spaces between H zone okay spaces between adjacent H zone remains constant antini mo hei ka soi fi ang okay remains constant antia chuan chumi ba ka chuan ingen soi chu length of H zone keeps on decreasing okay H zone na decrease charang okay chuan length of Z or let's say distance between adjacent Z lines keep on decreasing okay chem an soi chu enge hemi pali awang hian okay hemi thil pali hi aning nga na ni milemin kan soyang kan inang o sliding filament theory ina soi chu enge muscle kha en chuan la hian thick filament ni ya thick filament thin filament tiru tikhan lo umta se la hian thick filament la hian thick filament okay a zia chu enge muscle hi contract ma se khoilai nge a band kan ti chu helai hi in sha tiru a band hi angai charang okay ama ero chu helai hi in region nge kan ti kha helai region hi H zone kan ti tiru H zone hi a decrease charang okay hi a decrease ang chuan hetlai hian H zone a ve thawa tiru lai hian H zone a thawa ama ero chu distance between H zone helai region hi chu a in thak dang lam chuang lawanga okay chuan engen soi Z line helai Z line le Z line in car hi a decrease ang atini mo sliding filament theory chuan a chan chu helai hi a decrease chuan helai le helai in car chu enge sarcomere ni in chatiru sarcomere kha a decrease do ni Z line le Z line in car decrease chuan a chan chu enge helai decrease na chan hi enge ni ta ang kan ti chuan because thin filament slides over thick filament ti hian an ron slide anga zia chu enge ta hian mo hemi hi atira heti ang chen kha hi thick filament lo ni ta se an ron slide sorry thin filament hi tia an ron slide awang hian okay ti hian an ron slide awang hian a chung an ron lu awang hian H zone hi ate tel in motiru H zone hi ate tela sarcomere hi headline ni chin kha aron Z mani okay gm chumi atang chuan enge kan mu chu kan hriat thei chu kan ti chuan fully contracted muscle a phei chuan sarcomere kha ron te tu na sarcomere tina kha an tet vek chuan myofibril a te ang myofibril a toi chuan a contract chuan muscle fiber a contract ang chu muscle a contract ang chu in chethiam tiru chumi awang chuan chumi enga tang chuan in englo theory an ron siam chuaka chu sliding filament theory kan ti chu ni okay sliding filament theory hi hian enge soi chu a statement chu sliding filament theory states that head of myosin kha initiatiru myosin head kha initiatiru head of myosin okay forms cross bridges with actin filament okay actin filament a head kha cross bridge ani sa shim okay it interacts with F actin and forms ectomyosin complex antini mo ectomyosin complex lai hian myosin hian head anzu inglawa chuan cross bridge anzu siama hei hi thick filament okay hei hi thin filament chuan head and cross bridge anzu siama ni head of myosin filament comes in contact with actin filament okay and they form ectomyosin complex sliding filament theory statement number 1 ni chu okay and statement number 2 chu enge kan ti chuan and statement number 2 chu enge kan ti chuan head of myosin filament okay thick filament initiatiru undergoes rotation or swiveling okay swiveling undergoes rotation or swiveling tian avir chara and hei hi avir chara then it pulls thin filament okay it pulls thin filament inwards okay inwards kan ti chuan enge towards H zone okay lai sarcomere a chung zong in ti zong hian thin filament an run slide ani okay so those are the theory of sliding filament proposed by Huxley and friends okay chiangem chumi chung chuan A band na increase lawang A band na decrease ve lawanga H zone na decrease anga ZD sinkara decrease ang ama ero chu H zone inkar angai rengang chuan overall changes in the sarcomere hi engwange kan ti chuan this is due to movement or sliding of I band shortening of I band towards the center of the sarcomere or inwards movement of actin filament wangani okay chiangem I band kha decrease zel don achan chu I band a chuan inge thin filaments an tiru thin filaments na kha thin filaments ho kha thick filaments ho ning khan anin overlap awang khan sarcomere decrease ang tiru sarcomere length a decrease anga distance between ZDs a decrease anga it will lead to overall decrease in muscle or muscle length or muscle contraction okay mechanism of muscle contraction kan enang mechanism of muscle contraction okay muscle contraction. Sliding filament theory na muscle contraction ummati na chan chu ectomycin complex formation na umwanga ni kan ti tiru ectomycin complex formation na uma actin de mycin khan complex an siama chumi complex a chuan mycin head kha a swivela a rotate char a chumi chuan actin filament kha sarcomere center a inward zongin apula chumi awang chuan ZD's distance between ZD's kha a decrease a sarcomere a decrease a muscle contraction a thlengani antini. Okay, this mechanism chumi soifiana chu enge mechanism chuni maya involves various biochemical changes. Okay, mechanism hian in hian biochemical changes chi sang sang a okay, biochemical changes chi sang sang wangin hetiang hi muscle contraction hi theng theiani ectomycin complex formation te rotation of mycin head te kha biochemical changes wanga umani. Okay, muscle contraction mechanism hi 1942 dai to khan Albert Georgi kanti hianin allow propose to ni a mechanism hi. Okay, at nu fe a 1963 vela khan another scientist called R.E. Davies kanti hian 1963 vela khanin aron revise le ni. Okay, chuan hemi mechanism kan kal tak tak ma hian insia tur poimo kasoyang mechanism tak tak kan kal ma hian muscle reng hi relaxation state a chuan relaxation state kan ti chu enge resting stage ani. Okay, resting stage a chuan muscle hi muscle a chuan enge kha tian membrane a umalom tiru muscle khan membrane ania hetlai hi muscle khala unita se. Okay, membrane ania a membrane chu enge sarcolemma. Okay, sarcolemma pon lam hi enge extracellular fluid ani tiru shem ECF extracellular. Okay, achung lampang hi enge intracellular fluid ani. Okay, ICF intracellular kan ti chuan cell chung. Okay, muscle fiber chung pon lam chu extracellular. Okay, chiangem insia tur poimo chu sarcolemma hi hemisarcolemma hi membrane ani tiru hemi membrane hi resting stage a chuan intracellular hi extracellular hi ECF zoga hi hetlampu hi ECF ve kani tiru ECF hi positively charged ani. Okay, chumi omsia chu enge electropositive tina ni. Okay, achung hi intracellular hi electronegative ani. Okay, inge electronegative kan tina chan chu negative ion san chak zo ka. Okay, an tam zo ka an chak zo ka chuwang chuan electronegative ani. Okay, pon lama chuan ECF a chuan positive ions an tam zo ka excuse me, positive ions an tam zo ka chumi wang chuan electropositive ani. Okay, ECF ka chiangem ICF is electronegative at resting stage. Chiangem resting stage a chuan chuan isia tur poimo le chu le bok chu hemi hi resting stage a an hian resting potential an nei ni okay enge resting potential chu kan ti chuan resting potential ani mai mo soifak ngai na ka shelawa resting potential na chan chu enge ions interaction wangani okay that is about minus 40 mv minus 90 mv velani mo muscle hi a relax chuan muscle a relax daw chuan ani lawania chiangem chuan ionic distribution kan en chuan ionic distribution hi kan en chuan intracellular fluid a hian cell chung zoka hian okay intracellular fluid a hian potassium ions le anions an tam okay organic anions an tamang okay organic anions kati chuan negative ions ho kha okay an tamang ECF a hian extracellular fluid a hian resting stage a chuan positive ions a po sodium te chuan chloride ions te po okay negative ions chloride ions te an tamang okay ECF a chiangem ionic distribution ka soi okay chuan hei nge resting stage a vek relax state a muscle ka a relaxing chuan headline sarcolemma hi initiatiru hemisarcolemma hian permeability anei ni initiatiru chuwang chuan sarcolemma hi resting stage a chuan it will be more permeable to potassium ions okay potassium ions tan khan permeability anga zo kang okay then sodium ions adu lo zok ti na ni chu potassium ions adu zok ti na ni chu chiangem chuanin sarcolemma will be impermeable to organic anions okay organic anions how kha tan khan permeability anei vak don lo ti na ni chu chumi awang chuan extracellular fluid kha electropositive ani a intracellular fluid kha electronegative ani okay heti ang stage a hian relaxed state a hian muscle is said to be in polarized state kantini mo muscle hi polarized state a kantina ni zia chuenge it undergoes polarization okay chiangem hei hi resting stage ani action potential is minus 90 okay chiangem chu resting stage alo nita shia chian tur potassium ions hi intracellular fluid a antama okay intracellular fluid a antama extracellular fluid a chuan sodium ions kan tiang chi hote chloride ions kan ti te antama heta chuan anions antambuk okay chuan khi hriat chian em tu ni a chan chu mechanism a khana poimo do ni chuan a mechanism a chuan kan lu tang o hei hin hriat chian to chuan polarized state atangin kan tran don o muscle kha relaxed state a chuan a mechanism a chuan kan lo lu ta ang -90 hi chu karap tel lawang chu ti chuan in thil nge thleng don ta kan lo enang a mechanism tak taka muscle contraction alo tranang mo chuan muscle contraction alo don ta a eng thil nge thleng tur chu kan ti chuan muscle contraction a don reng chu a masabera chuan it starts with neural impulse okay neural impulse a phodanga ya masabera chuan gm neural impulse kan ti chuan enge motor neuron okay innervation nerve muscle nerve supply to te chu motor neuron ni okay motor neuron te khan i nerve impulse an run siam don ani mo a zia chu enge i nerve reng chu tlai hianin nerve fiber in neya chuan tlai hianin nerve endings in neya in chatiru ti hianin nei ta chuan hetlai hi nge axon okay nerve hi chu shanin chapter danga okay chuan tlai hian muscle fiber lo nei ta nerve ending le muscle in khoi na lai hi we call it neuromuscular junction kantini antini mo ati tu zinga katel velawa midang soyania neuromuscular junction kantia chuan neuromuscular junction a hian helaya hian muscle le neuron inzom na lai ti na ni chu okay headline inzom na laya hianin synaptic cleft kan ti kha thin okay synaptic cleft kan ti kha thina ta chuan synaptic cleft hian engeron siam chhuak thin kan ti chuan neurotransmitter an ron siam chhuak thin okay an ron pe chhuak thin neurotransmitter nerve impulse kan ti khan i thil dang dai de wani lawa in the form of chemicals in ron kaltin ani chu okay neurotransmitter chu enge chemicals anni oh hey chinchia tur oh point or the region where neuron meets with the muscle okay is called neuromuscular junction chuan neuromuscular junction atang chuan a synaptic cleft atang chuan neurotransmitter te hian a neurotransmitter an run secreta synaptic cleft atang khan neurotransmitter kan ti zingami pakhat chu acetylcholine ani okay ACH in short okay acetylcholine kan ti hi neurotransmitter chi khatania ACH kan tia short form in ACH hian synaptic cleft synaptic vesicles te khan neurotransmitter ACH anrun release chumi ACH hi engtin nge anrun release kan ti chuan the process is simply exocytosis okay headline synaptic cleft vesicle te khan tian exocytosis mangin ACH neurotransmitter ACH khan run anrun da chuak to pang cell pona changin cell chunga changin cell pona muscle an run pedon ti na ni chu okay chumi process chu cell chunga changa pona ida chhuadan process akha exocytosis kan ti chu ni mai okay thil dang ba kan lo process is exocytosis okay chuan chumi ACH chuan engna nge atho kan ti chuanin ama sabira chuan neuromuscular junction a ACH an run release a kati tiru chuan nerve impulse run kala ACH an run release a hemi a second step a chuan mechanism second step a chuan muscle contraction second step a chuan ACH hian ing na nge atho mo kan ti chuan hemi hi ACH receptor an omani mo receptor hi an lo dong song don khoyangin receptor is in sarcolemma. Okay, plasma membrane kan tiang chi muscle ina a plasma membrane a sarcolemma helai hawa hian ACH receptor an ti na ni chu. Okay, receptor how chu protein an ni tlang puya sarcolemma a receptor de khan ACH an lo receive ta a. Okay, ACH an receive chia khan danglam na a don ta he layami hi mo ta hian plasma sarcolemma a extracellular fluid electron positive nitrogen intracellular fluid electro negative nitrogen akha an run ti danglam don. Okay, engting an run ti danglamang kan ti chuan polarized state a hetlai thin kha depolarized state an run depolarization a don. Okay, chumi a thlen chuan plasma lemma hi depolarized state a run omang chiangem depolarized state a run omang a zia chu enge a ma khan enge ka soi kha sarcolemma is more permeable to potassium than sodium in resting state kati khain tiru ma se khatiang khani to do no ama a potassium du zok thin khan tuna chuan potassium in sodium permeability hi aron increase to don. Okay, more permeable to sodium than potassium ron ni to don. Okay, shetiamem sodium hi khoyangen tam kati kha extracellular fluid an tama. Okay, khoyange I potassium an tam kati intracellular fluid an thin hetia thin akha this is polarized state mo depolarized state a chuan engthil nge thleng tur chu ti hian sarcolemma khai ne ya tiru chuan ta hian ACH receptor in ACH a receive vele khan engthil nge thleng tur chu membrane hetia enge kha achung lampang zok electronegative ni a upon lampang zok electropositive ni thina kha ACH unreceived chia khan a in thla kanga depolarization a don depolarization a chuan nge ama a sodium du ngai mi a lo sarcolemma khan sodium influx a tir don. Okay, chu chuan membrane hi aron thlak dang lamang. Okay, membrane hi aron thlak dang lamanga a chunga hian danglamna ron thlenang. Oh, jeng she thiam tiru chan chu ama chuan sodium an ron lut thei lo chu wang chuan negative ion san chak zo ka tuna chuan sodium an ron lut thei to a hei permeability ron increase awang khan ACH binding awang khan positive ion san ron lut ta ka chuan depolarized state a sarcolemma to don. Okay, chumi rual chi a chuan depolarized state a awang khan resting potential minus 90 ni thin kha plus 45 to 50 MV vela hian anron increase do na ni. Okay, chiangem membrane potential ronin thakang. This is what we call action potential. Okay, action potential hi aron to don 45 le 50 in car vela aron don. okay ma minus 90 ni trin kha chumi chu action potential la ron chia chuan eng thil nge thleng tur chu hemi hi action potential chu impulse ani in chia tiru chumi impulse chu a travel don ani mo a number 3 a chuan action potential will travel along the tubule okay the tubule la te chuan sarcoplasmic reticulum te kaltlang ten chuan chumi baka chuan ZDs kain tiru ZDs or okay let's say ZDs or Z line in tiru chemical tlang te kan ti tubule hi enge kan ti chuan this is invagination okay invagination of sarcolemma okay sarcolemma akan plus and plasma membrane muscle fiber plasma membrane sarcolemma akan invagination umani finger like projections ang chi kha aquar lut ang chi kha ti na ni chu okay chu ti tubule kan ti chu ni okay chuan sarcoplasmic reticulum in tiru endoplasmic reticulum ti ang thau khani chuan ZDs or Z line kaltlang te khan Z line chu membrane thau ania in tiru chemical tlang khan action potential hi akalang okay action potential akal chuan eng thil nge thleng tur chu headline a hma a negative charge ho te hi anin thlak vekang chuan anin thlakanga chuan eng thil nge thleng tur chu ti hian akal char eng headline chang hian tian spray tanga shetia mem along the length of the muscle fiber or myofibril akhan okay 3 to 4 meter per second velin okay kalchar doni current tia kalchar angkhan light indotin lo chi taula current hetia kalchar angkhan mo 3 to 4 meter per second velin tian kalchar nga depolarization khatheng char don depolarization kan ti chan enge change in membrane potential atheng char don okay chan chu enge action potential a umalom in tiru action potential velocity hi 3 to this is velocity okay achak zong velocity hi 3 to 4 meter per second vel tlan charang okay chuan eng thil nge thleng tur chu adut le a chuan number 4 a chuan tlai hyang kala ziak shamang khami action potential 45 to 50 MV vel khan eng thil nge a eng lo tur chu a thlen tur chu kan ti chon hetia kal hian muscle chunga chuan tlai hian thil tam takan in tiru muscle cell chunga hian mitochondria te sarcoplasmic mitochondria or mesosomes kan ti te chuanin sarcoplasmic reticulum kan ti te cytoskeleton se thil chi sang tam takan muscle chunga khan in tiru muscle cell chunga khan so eng thil nge thleng tur chu kan ti chen action potential ma wang khan 45 to 50 MV vil khan sarcoplasmic hi okay sarcoplasmic reticulum hi avathleng ani mo avathleng ta a sarcoplasmic reticulum a hian enge thin kan ti chuan hemi chunga hian sarcoplasmic reticulum is the storage organelle for calcium ions okay calcium ions an tam takan pa yani hi sarcoplasmic reticulum hian okay chuan sarcoplasmic reticulum tam takan paia action potential hian sarcoplasmic reticulum avat hen chia khan engthil nge thleng tur chu kan ti chuan it induces a protein, very large protein, one of the largest protein molecule, okay, called dystrophin. Kanti hi ava induce ani. Oh, dystrophin hi avati active a chuan dystrophin hian sarcoplasmic reticulum hne hian sarcoplasmic reticulum hne hian avakala dystrophin hian chuan sarcoplasmic reticulum hne khan calcium ions release ro avati ni, okay, dystrophin khanin calcium release turin avatita, okay, biochemical changes atheng ti na ni chu, okay, chutia dystrophin ina hetlai karap tuang dystrophin ina sarcoplasmic reticulum hne na calcium ions release tura avati ta ka chuan calcium ions an release ta ka chuan engthil nge thleng tur chu kan ti chuan hetlai englawa hian intracellular fluid intracellular hian in shatiro intracellular fluid muscle chunga khan mo ta hian an sarcoplasm hian calcium ions tam takan umlon, okay, sarcoplasm khan an cytoplasm mani chu sarcoplasm chu tahan calcium ions tam takan lo to don ta ni mo kami calcium ions tam takhan calcium ions tam khan engthil nge thlen kan ti chuan calcium ions le magnesium ions te hi they act as cofactor, okay, cofactor for ATPase mo ATPase ta na cofactor ni tiom sia chuenge ATPase chuan engna nge tho it hydrolyzes ATP into ADP and inorganic phosphate baka they release energy, okay, in shatiro chuan hei hi calcium a umlo chuan a thleng don lo magnesium a umlo chuan a thleng don lo ATPase hian calcium le magnesium tel loin na a thok thei lo, okay, chuan han ngai tua ta ula ATPase hi enge nei tu ka ti khain la sha structure of microtubule ka soilai khan structure of myofilaments ka soilai khan myofibrils kan soilai khan myosin actin tivel structure ka soilai khan in sha tiru myosin he ta khan ATPase kan ti khain sha tiru khatlai mi khani mo myosin he ta ATPase hi anva activator calcium ions sa umta ka chuan a inactivator chumi chuan ATP hi ADP le inorganic phosphate le energy a aron convert ta ni, okay, chuan thilpoi mo tak chu enge energy lo nei ta, okay, chuan energy lo nei ta a hei karapang energy lo nei ta a chuti rualbok chuan engthil nge thleng tur chu kan ti chuan calcium ions hian enge kha actin filament ka soilai khan in la sha chuan troponin C ho kha in sha tiru troponin C khanin calcium an bind thin kan ti khain sha tiru troponin kha subunit pathuman oma chuan pakhat tropomyosin a in baina chuan actin filamenta chuan hei hi troponin C ni hei hian calcium lo bind thin bokani mo calcium a bind lo chuan hetia a betan chuan hetlai hian active site te khalo ta se an mass thin ani mo active site of hei hi actin, okay, actin ania chuan hei hi myosin active site myosin run bind tu turani binding site, okay, actin a khan an oma kha troponin khan in an mass trina khami an mass trina kha I calcium a chia khan troponin ho khan calcium an bind dai awangin active site for myosin kha an ron expose ta a active site for myosin an ron expose ta ka chuan active site for myosin exposed in actin filament. Okay, actin filament an ron expose ta chuan. Okay, an ron expose ta chuan eng thil nge thleng tur chu adot lia chuan formation of ectomyosin complex an ron siamang. Okay, ectomyosin complex an ron siam theita achan chu enge actin site a khan ahma ahlia khu thin tu kha calcium in alak pen ta ka chuan myosin tan hian run bain na tura ta ni tlai hian chu wang chuan eng thil nge thleng tur chu tlai hian milem kan zia kang okay ka ziak zuai zuai yang